You are and don't want. I'd like to be in. You decided to said you don't have homework almost every day.
That is factual. Everyone turn to the sideboard. Monday the 25th of November, our only day of this class for this week, okay? We discussed your test. We already did that. SWBA, students will be able to find slope and rate of change for 4B. Okay, we did 4A last time. Nate.
Will you get a fun sock Tuesday this week?
Okay,
No.
show us your fun socks. That you did on Friday.
That I did on Friday. If you have time at the end of class.
Oh, now.
I need to give you my Snapchat.
No, you need to show us the Snapchat.
So it's Snapchat. Yeah, I can show you guys a Snapchat from last week. If we have time at the end here, which I believe we will. Okay.
Chris spent like 4 days texting the student council Snapchat trying to get a response, and they kept leaving him unread. It was amazing. I don't have Snapchat.
Okay. So, me llamo Mr. Fossil. Make sure to write your name in there. Okay. Don't just write literally your name though. Right. There it is. Okay. So slope and rate of change. The slope of a line can be found even without a graph. Okay? It can be found even without a graph. We actually talked about that slightly before in one of the assignments, okay? As long as you have two coordinate pairs, as long as you have two pairs of coordinates, two ordered pairs, we can find it. Our slope formula is m is equal to y2 minus y1 over x2 minus x1, okay? Now once again, we kind of talked about this previously, just slightly, okay? This 2 and this 1 does not mean it's squared or anything like that. A square would go up above. This is going down below, okay? It's called a subscript. Sub means below, like a submarine or subpar, okay? So this 2 and this 1, this 2 and this 1, they are all written down below, okay? So I below to the right instead of up above. So what this is saying, this is the second y, this is the first y, this is the second x, this is the first x, okay? And as we notice, the second y is first, so the second x is first. The first y is second, so the second y, or the first x is also second. Yes.
Do I have to write that? It's just confusing me.
Yes.
Can you please read it?
Okay. So you can also think of this as, we call it delta y over delta x. This is the Greek letter delta. It's a Greek letter delta. It looks like a triangle, okay? And what that means for math is it means change. It means change. It's saying what is the change in y divided by the change in x. And hey, if it's changing in y, that's how much it's rising or falling, right? Okay? And if it's changing x, it means how much is it running left or right, okay? So another way you can word this means the change in y over the change in x. It's how much are the y's changing and how much are the x's changing, okay? Those are our two coordinate pairs. Because the change between two things, you would subtract them. To figure out how much are they different, you would subtract. So say like, hey, if your bank account was something and now it's a new number, how would you figure out how much changed? You'd subtract the two numbers and say, oh, what's the difference there, okay? It doesn't matter which point you start with for y, okay? As long as you start with this corresponding x in the denominator, okay? So we're saying, hey, if we're given two coordinate pairs, it really doesn't matter which y we start with, okay? But the x has to match up with that. So if you start with that y, you start with that x on the bottom, okay? And we make sure to reduce our slope when possible, but we know that, okay? We're going to practice this here. Examples. We have two coordinate pairs, okay? We have two coordinate pairs. Now, they're both x, y. They're both x comma y, right? This is an x comma y, and this is an x comma y, correct? Okay? Now, do we know which one's x1, y1, and which one's x2, y2? Not necessarily. And we don't really care which one's which. We really don't care which one's which, okay? So for grins and giggles, we'll just call this one x1, y1 because they come first, and this one x2, y2 because they come second, okay? So if our equation for a slope is m is equal to y2 minus y1 over x2 minus x1, okay? Then we'll say, okay, well, where do we put 14 in at? For y2, so I'm going to plug 14 in there. Okay, and what goes in the y1 spot?
The first y.
The 5. That's y1. And what operation goes between the two? Subtraction. And that's over what minus what?
6 minus 4.
Very good. 6 minus 4. Okay. It goes, and then it goes over that 6 minus 4 there. Okay. So I'm plugging those in because 14 was first for our y's, 6 has to be first for our x's. Okay? Because 5 was second for the y's, that x4 has to be second as well. So then we say, okay, well, what is 14 minus 5? 9. And what is 6 minus 4? 2. 9 over 2, can that reduce? What goes into both 2 and 9? Nothing. Okay? If you can make it a mixed number if you want it, but we don't want it as a mixed number. This is our slope. 9 over 2. We would know how to graph that, right? We know how to graph using our slope. Okay? So we're just finding the slope with the numbers right now instead of counting them. Okay? Instead of counting them, you can also find them this way. So if you don't have a graph, you just have 2 ordered pairs, 2 coordinates. Okay? That's good. Okay? Let's take a look at what would have happened, guys. Okay? If we had switched them around. Let's say we had put, you don't have to write this part down. Let's say we had put 5 first, and we put minus 14. If we had 5 minus 14, okay? That's perfectly fine, but what do I have to do on the bottom now? I put 5 minus 14 on the top, so do I still put 6 minus 4 on the bottom? No, what do? I put 4 minus 6, okay? Because this 5 went first, the 4 has to go first. What is 5 minus 14? Negative 9. What's 4 minus 6? Negative 2. Hey, what's a negative divided by negative? So we still get the same thing, don't we? So that's why we say, hey, it doesn't matter which point you really start with. It doesn't really matter which ones you call y1, y2, or x1, y1, and x2, y2. It really doesn't matter, okay? As long as we're just staying consistent with which one goes first. Okay. So let's look at the second one here. Negative 3 comma 6, 5 comma negative 8, okay? Yes, okay? So, we don't have to label our x's and y's every time, okay? You don't have to label our x's and y's every time. And somebody said at the top for me, Kelly. 6 minus a negative 8, okay? I like to put them in parentheses because I think it makes it's more clear to see what the negatives, what's going on there, okay? So based upon how Kelly set up the top, how do we have it set up the bottom then?
Weird. Oh,
Maybe.
negative 3 minus 5.
Negative 3 minus 5, okay? Why could we not do 5 minus negative 3 on the bottom? Yeah, that'd be mixing up our coordinates, okay? That'd be mixing up our coordinates. So because Kelly did 6 minus negative 8 on the top, which is perfectly fine, we have to do negative 3 minus 5 on the bottom. If Kelly had done negative 8 minus 6 on the top, we'd have had to switch the bottom around too, okay? So it's about all based upon how you do the top dictates how you have to do the bottom. Sometimes. Let's look at what happens here, though, as we look at which ways might be easier for us or might be simpler for us, if we can choose. What happens with 2 negatives in a row, guys? Positive, okay? And we like adding, don't we? Okay? What's 6 plus 8?
8.
Yes, 14. Negative 3 minus 5, and negative becoming more negative is? Negative 8. Does this simplify at all? To what?
7 over.
Negative 7 over 4. Does it matter that I move the negative from the bottom to the top? No, the negative can be anywhere on that fraction. It can be top, bottom, out in front, but that's our slope. Okay? So sometimes for us it's easier to do, to create that double negative. Sometimes we might think, oh, maybe we just want a bigger negative number, and sometimes it might not matter. Okay? I want you guys to try number 3 on your own. When you have it or think you have it, or have questions, raise your hand, please, okay? Thank you. I'll have you sit there. Thank you.
all the.
No, she has some appointments today.
She has something more important.
Family business.
So-
Oh.
Oh.
Well, and now we have. Yes.
What needs,
Uh,
Maybe he wanted me to do it in the future.
That's the thing you can actually do now, you can decide for the child.
Oh my
Stupid.
God.
You're not allowed to drive till you're 16, but your 7-year-old's allowed to decide to chemically castrate at the age 7.
So their chromosomes. So I think it was better Sorry, I had to take it off.
Guys are calling Kitty Kid.
I have spoken.
Let's talk about this one up here, guys.
I'm gonna tell Chief that.
Hey, Chris, tell me how you set yours up.
I did 2 minus 0 for the top.
And I can plug in them parentheses. And what did you do on the bottom then, Chris?
5 plus 1.
Okay, -5 minus -1, which creates
Oh,
plus a positive.
I wrote it wrong.
What's 2 minus 0?
-2.
Well, in this case, it'd be positive, but yours might have been negative. We'll see that.
It's 2 minus.
-5 plus 1 is
-4.
-4. What is 2 divided by -4?
1/2.
1/2, but it's negative, okay? Once again, it does not matter where a negative goes, okay? So if you switch up your coordinates, did you still get the same answer, though?
Yeah.
Yes, okay? So if you did your coordinates in the other order, you still get the same slope. It's the nice part about slope. It doesn't matter which one you go to and from first, okay? Yes, Kenny?
Is that a bird's nest with a little bird inside?
No.
Yes.
What is it?
It's a mask that's like correct.
Yeah, because Chris hit it.
No, it's
It was
supposed
on
to.
your face.
Anyway, okay, what's thought? Questions on that?
Oh, number 5's kind of confusing because they're both the same one. So basically, you can just put them in.
It was self-defense instead.
Okay.
Sees the.
Voice off. Okay. Let's walk through number 4 here, okay? Ben, why don't you set up number 4 for me, please?
Okay, 10 minus -3.
Not quite. What are those? Are those X's or Y's? Okay.
7 minus -3.
Okay.
And -3 minus 10.
So Ben did 7 minus -3, so the bottom had to be -3 minus 10. Okay. So on the top here, we have 2 subtraction signs in a row, 2 negatives in a row. And those are positive, because anytime you subtract a negative, you're really adding a positive. Okay, subtracting is doing the opposite of whatever's there. Okay, so 7 plus 3 is 10. -3 minus 10, 2 negatives become more negative. So that gives us a -13. Can that be simplified? No. So 10 over -13 or -10
Wait
over
1 second.
Okay.
Wait 1 second.
Okay.
I did 7. Y1 over is minus Y2. X1 over X2. So that would be
You did
10
your
over
X's on
13.
top instead.
That way they would, I did Y.
But one of them needs to be negative, okay? So set the
Oh,
you have
the
negative
answer I
minus
asked
10.
for was also like
I
this
got
Oh,
that.
it's here.
agree in school.
Look, is it the wheelie kind? You put little wheels on, so you just drag it around.
It just has to be
So good catch, okay? Hey, next one here, okay? Seth noticed something interesting about this one. What do we notice about the Y's here?
The same.
They're the same, okay? So, which Y do you want to put first?
Doesn't matter.
Doesn't matter, okay? Either way, it's 6 minus 6. Okay, that's really bad, like.
Already 0.
And then, so at that point, does it really matter which X we put first since the Y's are the same? No, okay? So we can put, I would try and do 5 minus a -11. Why would I try and do 5 minus a -11? Because we're going to get a positive number. If you want to do -11 minus 5, that's also fine. Nothing wrong with that at all. I prefer to try and keep the numbers positive, so I like to put the negative number second. If I have a choice, I'd like to put the negative number second, because then, boop, boop, we're dealing with positive numbers, okay? So I like to put the negative number second, okay? A lot of times. So 6 minus 6 is
0.
0.
Uh-oh.
5 plus 11 is 16. Hey, wait, did it really even matter what the bottom was? Because what's 0 divided by literally anything?
Zero.
0. So our slope is 0.
So that means, what is it then?
Is that a horizontal line or a vertical line?
It could be either. No.
It's a horizontal line.
Oh, that's
Slope of 0 is a horizontal line. It's not rising at all. It's not rising at all, okay? Okay. So, with the slope here on our last problem, here, okay, number 6, 14 comma 7, negative 2 comma negative 3, okay? If we like to put the negative number second, what numbers would we put first here? 7 minus a negative 3.
14 minus
And 14 minus a negative 2. We don't have to do it that way, but I think life's easiest for us when we like to try and put those negatives second, because subtracting a negative, adding a positive, subtracting a negative, adding a positive. Now we're dealing with positive numbers, and we like positive numbers. What's 7 plus 3? And what's 14 plus 2?
15.
Can we simplify?
Yes.
Into what?
5 over 8.
5 eighths.
5 over 8.
5 eighths. Okay?
Oh,
5 eighths. Okay? So it ends up
Nate,
simplifying
where are
into
your
5
five
eighths
up-
there,
where are your
okay?
four other pieces?
That's please
Okay,
that's forward.
nice.
That's please that's forward, okay? Thank you, okay? Now, another thing I want to point out with these guys, even though we actually didn't have any of these examples, okay, is that when we were subtracting, okay, let's say if we had only positive numbers we were dealing with, okay, like on our first one, we dealt with positive numbers, okay, I like to pick the bigger number first. So if you have no negative numbers, I would like to put the biggest one first. Because anytime you take a bigger number minus a smaller number, you're going to get a positive, okay? We like dealing with positive rather than negative, okay? We have more negative signs, we're prone to make a little more mistakes, okay? Does that make sense? You don't have to do it that way. If it makes more sense for you to do, I'm going to put the first one first every time. Go ahead. I want you to do what makes sense for you. As long as you're doing the math correctly, I'm good with that. Questions on these 6?
It's just they're the same negative.
So, rate of change. We're also going to be talking about rate of change. So it said slope, and now we're also going to use rate of change here, okay? So, that's what our learning target said today. They said, hey, you're going to be able to find slope and rate of change. We found slope. Now we're going to look at finding rate of change, which is actually, as we'll find out, basically the same thing, okay? So, rate of change is a ratio. It is a ratio, okay, that describes, on average, how much one quantity changes with respect to a change in another quantity. This is talking about all the types in science, okay? It's saying how much is one changing in respect to the other, okay? So for every how many of this is this changing how many, okay? It's kind of like a recipe. That's where a lot of times we see ratios, right? Okay? Maybe for every 1 cup of flour, you're doing 2 cups of sugar for something, okay? I'm just kind of spitballing there. So if you do 2 cups of flour, how many cups of sugar are you doing? 4, okay? If I double one, I have to double the other, okay? So if x is our independent variable, do you guys remember independent and dependent variables from science? Okay?
Oh, yeah.
If x is the independent variable, and y is the what variable then?
Dependent.
Dependent variable, okay? If x is the independent variable, y will be our dependent variable, okay? We'll say that whatever y is depends on x. Just like we found out with our functions, okay? We plugged in x, we got out y. Stop. We plugged in x, we got out y, okay? So x was the independent, y depended entirely on what x was, okay? So our ratio of change, our rate of change here, will be the change in y over the change in x, okay? Once again, that's change in y over the change in x for our rate of change. So you put your dependent on top, your independent on bottom. And hey, have we seen this before? Yeah, where did we just see it a few minutes ago?
4.48.
Okay, but where did we see it just a few minutes ago? What were we talking about that with? Call it the
Slope.
call it the slope. Okay, so slope and rate of change are really going to be the same thing here, okay? So, here we have a table. We're going to use this table to find the rate of change. And we're going to explain the meaning of that. So we have time walking. We're told what variable is that? X, our independent. Distance walked is what variable? Y, and that's our dependent, okay? We're saying how far you walk depends on how long you walked. How far we're walking depends on how long we're walking, okay? So, if we look at our x values, how much does it change from 1 to 2? Okay, it's adding 1. How much is it changing from 2 to 3? adding 1. How much is changing from 3 to 4? Adding 1. So every time we're adding 1 second. Okay. Well, how much distance are we walking? How many feet are we adding from 5 to 10?
Paradiddle.
Okay. How many feet are we adding from 10 to 5? Okay, let's try a number though. Okay. How many feet are we changing from 15 to 20? 5. Okay. So the changes are consistent, right? So if you change after changing once, after adding on 1 second, how much more distance do you end up walking? 5. So our rate of change is 1 over 5. And what that would mean, should be not 1 over 5, rather, what variable should we put on top? Excuse me. What variable should we be putting on top there?
Y.
So y, so it should be 5 over 1. For every 5 feet you walk, you have 1 second. So you walk 5 feet for every second, okay? So somebody tell me how we could write a sentence or a small sentence describing this rate of change. Elliot.
You walk 5 feet per second.
Yes, you walk 5 feet per second.
I don't think.
What's another way you could word it that's really the same thing? You walk 5 feet per second. What's another way we could word it that really says the same thing though? As well.
5:1.
Okay. Another sentence. We could say for every 1 second. Very good. For every 1 second, you walk 5 feet. You could really say either of these. Okay. I'm just trying to give you guys ideas. Okay. And you know there's more than one correct answer. For every 1 second, you walk 5 feet. Either way, we're communicating the same thing.
That's not that hard, I don't think,
Okay.
5 feet per second. At least for the average male adult.
I guess so.
Maybe, we
Okay.
don't know. I should try this.
I'm quite a slow walker. Okay. Questions on that? Let's flip the page. We have one more example here, and then we're done with the notes today. Okay, does that sound good to you guys?
Yeah, no,
Okay, are you guys okay with that? Okay.
Still mad, Mr. Consul.
I still
mad.
mad
That
at
was
Mr.
funny.
Consul. Oh, you said you were still. You said you're mad?
I'm still mad.
Oh, are you okay? Ooh,
Wait, I
okay.
think it's funny that you ignored the fact that Chris was on his phone.
Yeah.
Chris, get off your phone.
I'm not
Oh,
on
are
my
we
phone.
not gonna talk about that?
Yeah.
today? I don't care, I
Well,
thought it was
since
funny, he
everyone-
like came out and was just like.
Yeah, I was like,
Look me in the eyes.
I was all serious. My Kenny, never doing this again. Okay, it's not appropriate. Okay.
I was
Come
like,
back
alright.
in, show the class.
Alright.
Okay, take it back out. Here's another one.
I just went, I guess.
I mean,
Well,
you
the reason
just
we
have-
looked
I really wish you had already started on it. Because it'd have been
That's
funnier
why-
to me.
Well, I
if
That
you
is
had
why I
taken
was on my
this
phone.
class.
I'm
You know
getting
you were. It was
that
blank.
If you would have got
That's
to,
why I
It was
was
blank.
you would have got to like the very last question. You
I don't know, I thought I started.
You did.
In my head I did.
Okay, well you didn't in actuality. In the year 2000! Cannot be confused with 3,000 Jonas Brothers, okay? The population of Gretna was about 2,300. The town's grown a lot, so we're using that, okay? In 2010, the population was about 4,400. It grew quite a bit. It grew quite a bit. What was the rate of change during this time, okay? So what was the rate of change during this time, okay? So here's one of the questions we have to ask. What are our two variables? X and Y, independent, dependent, okay? And what are they describing?
Time and people.
Time and people. Now, which one of those is more likely to be independent?
Time. The year.
Time. Anytime you have time, it's going to be independent. Because time moves on regardless. It doesn't depend on other people, okay? Time is going to be our independent, okay? So time, our years, okay, is going to be our independent, our X, okay? So what's that make the dependent, the Y? What's that make that? People, population. Okay? So, to find out the rate of change during this time, what do we have to do? Add.
take the 2,300 never mind.
Which one do we like to have on the top? The Y's or the X's? Y's, okay? Blessing must rain down, half must forget. So blessing must rain down, half must forget. Okay? So, what are we going to be putting on top of a fraction here? We make fractions. What am I going to put on the top of a fraction? Okay, we can put 2,300 if we want. Okay? And then what would we put after that? No? 2,300 people and what?
4,400.
And what operation would I be doing? Okay? Blessing must rain down, half must forget. Now we could put these in either order, couldn't we? So would we maybe prefer a different order?
No.
What order might we prefer, Ben?
4,400 minus 2,300.
We might prefer 4,400 minus 2,300. It's not that the other one's wrong, but this one might be easier for us, might it?
Yes.
I I think we'd rather think of it this way, big minus small rather than small minus big, okay? So if we go back to the first one, if we do it this way, 2300 minus 4400, okay, the same thing as 2300, 2300, okay? What did I put on the bottom here?
The
2000 minus 2010. Now on the bottom, wouldn't we rather also have the big minus the small? Okay, so we'll switch it around over here. 2010 minus 2000. Okay? So this is going to be our M, our rate of change. Okay? So if we actually do this problem, 4,400 minus 22,300. Okay? That might look a little more intimidating to us at first, but if we cover up these zeros, what's 44 minus 23? Hang on. That means put that zeros back on. What's 2010 minus 2000? So we have 2,100 divided by 10. Okay? Now here's the thing. What was that?
Oh, I mean.
Okay. So we also like to do what with our fractions after we're done? Simplify. Is there anything we can reduce here? 10. What's our trick with 10? Cross out the 0. So you really have 210 for every 1. So what's that mean? Somebody tell me what that means. Kenny.
You have about 210 people per year.
Yeah, the population increases by 2010 per year, by 210 people a year. So the population has increased
I don't.
by 210 people each year. Now, would it have likely changed exactly 210 people every single year?
No.
No, some years were probably higher, some years were probably lower.
Some
Okay,
people
boomers.
want to change.
okay, yes, boomers. Okay, so
Very well.
some of them probably changed inconsistently there. Okay, but that's okay. We're just trying to figure out what the average is. We're saying on average, about 210 people moving there every year. Okay, from this time span. Okay, questions on that? No, but we could have.
Population change?
It's pretty big, but
Yeah,
Yeah.
What were these
2010,
folks
they would've
doing?
had
that town's also growing a lot.
rap.
Yeah, they need to know it's school.
Rabbits?
I say it's because they just want to still beat us in all.
I'm not just gonna freak like people
If
say
you
they
can't
A
feed
lot
them,
of
no.
family reunions happen.
Can't beat them.
Wow.
Join them.
No, it's not what it is.
It's Star.
Yeah, Star Wars.
Voices off, please.
You can't beat them. Join them.
Okay. We have a Pank worksheet today. Hank.
There is no Wednesday this week though.
I can see your.
I have a paint worksheet.
Oh yeah, so today is like a college day. So for teachers, so we're wearing college shirts. Okay. So I'm wearing and so I'm wearing my hoodie I had from college from my soccer team. And then underneath it, yes, rest in peace. And then underneath it, I have my shirt from there.
Oh, is that the
pink shirt?
Grace University?
Yep. That no longer exists.
Yeah.
Look at the hospital that I was
This
born. I
is
got burned down.
pre-K. We didn't go.
So,
Mrs.
It was in the
Gray,
California wildfires, genius.
hey.
Mrs. Gray.
So on the first 5, we're just reviewing finding slope like we did before. On the first 5, we're reviewing finding the slope from before, okay? So even though we didn't go over that today, we've done that before, and we just tested over that as well, okay? On the back, 6 through 10 are true or false. 6 through 10 are true or false. 11 through 18, you're finding slope giving the 2 coordinates like we did in the notes, okay? And then 19, you have a word problem like we did in our notes as well, okay? So, you guys may work on this. There's a good chance a lot of you could even get this finished today in class. Okay? You guys may listen to music as well, okay? That way Chris doesn't even have to ask that question today, okay? You guys may listen to music just on your phone or your music or whatever device you're using.